Gymnosperms. Gymnosperms are your cone-bearing trees. Think of conifers, a great example of this, and there are many different examples. Great example are pines. There are many different species of gymnosperms. We see them appear on the evolutionary timeline for plants about 360 million years ago. They have adapted to withstand very long, harsh winters. So in order to adapt to this colder and drier environment, their main adaptation we're going to see in these 3 bullet points here, seeds. Seeds first evolved here in the gymnosperms. And seeds are going to be used as a packaging system to help protect that very delicate embryo. In addition, for protection, it also provides food storage for the developing embryo. So it really helps with that reproductive event, now transitioning to a dry environment. Production of pollen as well. And pollen doesn't need an aquatic environment. In fact, it doesn't prefer it. It prefers a dry environment that's going to help transition and make its way towards the female gamete. In addition, we see the greater development of a sporophyte generation. I'm going to go over what this means right now. Plants, I'm going to teach you about an alternation of generations. Plants exhibit this quite beautifully, and I'm going to use, I think, bryophytes as an example as I explain this. So what I mean by an alternation of generations in that plants will undergo a diploid stage and a haploid stage, and they'll alternate between the two throughout their life. One of those generations is called the sporophyte generation, that's the diploid form, and the other one is the gametophyte generation, that is the haploid form of the plant. We'll go over this in more detail in a bit, but it is in gymnosperms that we start seeing a greater development of that diploid sporophyte generation. So to discuss that reproductive adaptation in a little bit more detail here in these gymnosperms, we see a pollen grain. A pollen grain is actually a male gametophyte, and they are going to develop into sperm. Here I can actually see on this ponderosa pine, this beautiful ponderosa pine, I'm actually looking at the sporophyte generation here, but here I can see this pollen producing cone. It's a very, very tiny structure compared to the female one that I'm going to point out right now. They produce male gametophytes. Ultimately, pollen grains are going to be produced in these structure types on the same plant. Here I see the ovule-producing cone. They're much larger, more protective than those more delicate, smaller male gametophytes. These ovule-producing cones, which are more obvious when you guys take a look at these beautiful gymnosperms out there. You're probably going to notice these female gametophytes more than these male, but you'll find both. I want you to try and find both out there when you look at a gymnosperm next time out there. In the case of conifers, like I'm showing you here, we have the event of pollination. Pollination is going to be the reproductive event where you have delivery of the male part to the female part. Pollen to female, and that is going to be sexual reproduction of these gymnosperms and angiosperms that we will discuss. I want to show you a pine. This is a female gametophyte, those large protective ovule producing cones. This is a 24-hour time lapse, so it's sped up so that you guys can see this. And these are seed-bearing pine cones that do respond to changes in the environment. So humidity is going to be a factor in that response. When there's a warm and dry environment, so think of spring, summer, the pine cone opens and releases the seeds. When it's damp or cold, the scales are going to close up. Think of late fall, winter, and we will no longer have the release of those seeds occurring around that time. So it is environment dependent how that event occurs. Okay. Here is this alternation of generations that I wanted to discuss with you all. So I have on here, I haven't talked about angiosperms yet, but I've talked to you about the charophytes, that ancestor, of plants. We have my bryophytes here, ferns, those seedless vascular plants. We have gymnosperms that we just discussed. There's a beautiful pine being shown there, and then angiosperms, which I have yet to discuss. Here I can actually see the alternation of generations occurring. So I have my sporophyte up here. This is the diploid stage of the plant life cycle. And then I have the gametophyte stage. That's the haploid stage of a plant life cycle. And what this image is showing you, it's a beautiful image where I can see down here, this horizontal line is indicating time. It's their time in the gametophyte stage, that haploid stage. Much of their life cycle is spent as a gametophyte, and a very tiny part of their life cycle is spent as a diploid sporophyte. That's what that's telling me. Ferns are kind of half and half. They'll alternate just like all other plants, but they'll spend about half of their time in that gametophyte stage, another half of their time in the sporophyte stage. For gymnosperms, we start seeing a large increase in time spent in the sporophyte stage, and here's the gametophyte stage. So when you actually physically look at a gymnosperm out there, you are looking at the sporophyte. You're looking at the diploid part of that plant life cycle. The gametophyte stage does exist. It's out there, but that stage is less apparent than that beautiful, huge sporophyte stage of the plants. The same concept is going to go with the angiosperm, in fact, even more so, where it spends a majority of its time in that sporophyte diploid stage. A little bit of time in the gametophyte haploid stage. To focus on that alternation of generations, once again, I do love this slide because it shows you in color the different forms of the life cycle. So here I'm showing you in pink, whatever's colored in pink is the haploid stage. That is the gametophyte stage. And whatever's colored in purple here is the diploid stage. That is the sporophyte stage. So here is showing me bryophytes. Remember I taught you that bryophytes spend the majority of their time in that gametophyte stage. There's that large structure here showing me that. Very little of it is the sporophyte, but it is still there nonetheless. And there's an alternation of the life cycles for that guy. If I go ahead and switch straight over to the gymnosperms over here, this image to the right, it's kind of a switch event there in the evolutionary timeline where now I have that much larger structure that is a sporophyte, diploid, and the much smaller gametophyte, that haploid stage in gymnosperms. So I kind of see those events reverse as I go along the evolutionary timeline.